Kotlin emerged as a new voice in the programming world. It was officially unveiled by JetBrains in the year 2011. JetBrains, a company renowned for its developer tools, conceived Kotlin. They are the creators of IntelliJ IDEA, a very popular Java IDE. Their expertise in developer needs directly shaped Kotlin's design. The language was named after Kotlin Island near St. Petersburg, Russia. This marked the start of a language built for developer productivity. It sought to address common challenges faced by programmers daily. Kotlin was not just another academic language, it was born from practical necessity. The primary motivation behind Kotlin's creation was clear. JetBrains desired a more efficient and expressive language. They needed this for their own substantial codebase, largely written in Java. While Java is powerful, it can sometimes be verbose. JetBrains envisioned a language that could improve upon Java's limitations, yet it critically needed to maintain compatibility with the existing Java ecosystem. This practical consideration was paramount. They weren't looking to replace Java entirely. Instead, they aimed to offer a compelling, modern alternative that worked alongside it seamlessly. From its very inception, Kotlin was designed with specific goals in mind. Pragmatism was the guiding principle throughout its development. The language aimed to solve real-world problems effectively. It focused on providing features that developers would find immediately useful. Safety was another crucial concern, particularly regarding null references. Kotlin's type system was designed to prevent null pointer exceptions. Conciseness was also a key objective. The language strives to allow developers to express ideas with less boilerplate code. This leads to more readable and maintainable software. Kotlin's strong connection to the Java Virtual Machine, or JVM, was a strategic choice. It was engineered to compile to Java bytecode. This means Kotlin programs can run wherever Java runs. This decision provided immediate access to the vast Java ecosystem. Libraries, frameworks, and tools built for Java could be used with Kotlin. This significantly lowered the barrier to adoption for Java developers. They could start using Kotlin in their existing projects gradually. This interoperability was, and remains, one of Kotlin's most significant strengths. It offered a smooth evolutionary path rather than a disruptive revolution. Interoperability is a cornerstone of Kotlin's design philosophy. It refers to the ability of Kotlin and Java code to coexist. They can understand and interact with each other within the same project. This means you can call Java methods from Kotlin. Conversely, you can also call Kotlin functions from Java. This bi-directional communication is remarkably smooth. It is not an afterthought but a core feature. This seamless integration makes Kotlin exceptionally practical for real-world development. Developers are not forced to choose one language exclusively. They can leverage the best of both worlds. This remarkable interoperability works because of Kotlin's compilation process. Kotlin code is compiled down to Java bytecode. This bytecode is then executed by the Java Virtual Machine. The JVM cannot distinguish between bytecode generated from Java or Kotlin. To the JVM, it is all just standard bytecode. This fundamental compatibility at the bytecode level is what enables such deep integration. It allows Kotlin to be a drop-in replacement or addition. You can add Kotlin files to an existing Java project. The project will compile and run without issues. This technical foundation is key to its success. A significant advantage of this interoperability is access to Java's mature ecosystem. Developers can effortlessly use existing Java libraries and frameworks in their Kotlin projects. Popular Java libraries like Spring, Hibernate, or Apache Commons work perfectly with Kotlin. There is no need to search for Kotlin-specific alternatives for every task. This saves immense development time and effort. It allows teams to continue using tools they are already familiar with. The stability and reliability of these established Java libraries are readily available. This makes Kotlin a safe choice for even large enterprise applications. For companies with substantial investments in Java codebases, Kotlin offers a gentle adoption curve. They do not need to undertake a risky wholesale rewrite of their applications. Instead, they can introduce Kotlin incrementally. New features or modules can be developed in Kotlin. Existing Java code can remain untouched and fully functional. Kotlin and Java classes can live side by side in the same package. This phased approach minimizes risk and disruption. It allows teams to learn and adapt to Kotlin at their own pace. This pragmatic migration path has been crucial for Kotlin's widespread adoption. Kotlin's syntax is intentionally designed for clarity and readability. It aims to be intuitive, making code easier to understand. This benefits both new developers learning the language and experienced programmers maintaining complex systems. When code is easy to read, it is also easier to reason about. This reduces the cognitive load on developers. They can grasp the purpose of a piece of code more quickly. The syntax avoids unnecessary ceremony. It focuses on expressing the core logic effectively. This simplicity contributes significantly to developer happiness and productivity. A major aspect of Kotlin's clean syntax is the reduction of boilerplate code. Java, for all its strengths, often requires developers to write verbose constructs. Kotlin systematically eliminates much of this verbosity. For instance, semicolons at the end of lines are optional in Kotlin. The compiler can infer them, making the code look cleaner. Type inference is another powerful feature. You often do not need to explicitly declare the type of a variable. The compiler can deduce it from the context. These may seem like small changes individually. However, collectively, they make a big difference in code size and clarity. Variable declarations in Kotlin are straightforward yet powerful. Kotlin uses to declare read-only, immutable variables. It uses to declare mutable variables. This distinction encourages developers to favor immutability. Immutable data structures lead to safer and more predictable code. They are easier to reason about, especially in concurrent environments. Making immutability the default is a deliberate design choice. It gently guides programmers towards writing more robust software. Understanding the difference between and is fundamental. It is one of the first concepts new Kotlin developers learn. Null safety is a standout feature integrated directly into Kotlin's type system. This is a significant improvement over Java's handling of null references. In Kotlin, types are non-nullable by default. If you want a variable to hold null, you must explicitly declare it as nullable. This is done by adding a question mark to the type. The compiler then enforces checks for nullability. This drastically reduces the occurrence of. These exceptions are a common source of bugs in many Java applications. Kotlin addresses this problem at the language level, leading to more reliable code. Kotlin's conciseness goes beyond just reducing visual clutter. It means developers can achieve the same functionality with significantly fewer lines of code. This is not merely about typing less. Writing less code often translates to fewer opportunities for bugs to hide. It also makes code reviews more efficient and less time-consuming. When code is concise, the intent of the programmer becomes clearer. The signal-to-noise ratio improves. Developers can focus on the business logic rather than wrestling with verbose syntax. This efficiency is a hallmark of modern programming language design. Data classes in Kotlin are a prime example of its conciseness. In Java, creating a simple class to hold data, a POJO, requires a lot of boilerplate. You need to manually write constructors, getters, setters, and methods. Kotlin automates all of this. By simply prefixing a class declaration with the keyword, the compiler automatically generates these standard methods. This saves a tremendous amount of tedious coding. A single line in Kotlin can replace dozens of lines of Java code. This feature alone significantly boosts productivity. Extension functions provide another powerful way to write concise and expressive code. Kotlin allows you to add new functions to existing classes without modifying their original source code. You do not need to inherit from a class or use design patterns like decorator. This is particularly useful for adding utility functions to framework classes. For example, you could add a function to the class. When you call this extension function, it feels as if it were part of the original class. This feature promotes code reuse and helps keep your code base organized. Kotlin also offers features like smart casts and string templates. Smart casts are a clever compiler feature. If you check the type of a variable using uncheck, the compiler automatically casts the variable to that type within that scope. This eliminates the need for explicit redundant casting. String templates provide an easy and readable way to embed expressions within strings. Instead of string concatenation, or you can use the symbol. For example, inserts the value of the variable. These features, while small, contribute to a smoother and more concise coding experience. Section 5. Kotlin in the Android world. Revolutionizing App Development. The Android development landscape changed significantly with Kotlin. Google announced official support for Kotlin on Android at Google I/O in 2017. This was a landmark moment for the language. It provided a strong endorsement from a major industry player. Android developers, who often sought alternatives to Java's verbosity, quickly embraced Kotlin. The announcement signaled a new era for Android app development. It promised a more modern, productive, and enjoyable coding experience. Kotlin rapidly gained traction within the Android community. Many developers started migrating their apps or starting new projects with Kotlin. Google's decision to adopt Kotlin was driven by several compelling reasons. Kotlin directly addresses many common pain points in Android development. Null safety was a particularly attractive feature, a frequent cause of crashes in Android apps. Kotlin's type system helps eliminate these. The verbosity of Java was another concern. Android development often involves writing a lot of boilerplate code. Kotlin's conciseness helps reduce this significantly. Furthermore, Kotlin offers modern language features like coroutines for asynchronous programming. This simplifies handling background tasks, a common requirement in mobile apps. The benefits for Android developers using Kotlin are numerous. Development cycles can become faster. Writing less code means features can be implemented more quickly. The strong type system and null safety lead to more robust and reliable applications. Fewer crashes mean a better user experience. Kotlin's concise syntax results in smaller code bases. Smaller code bases are generally easier to understand, manage, and maintain over time. This is especially important for large projects or teams. The improved developer experience also leads to higher morale and productivity. Many find Kotlin simply more enjoyable to write. Today, Kotlin is not just an option but often the preferred language for Android development. Many popular Android applications are now built partially or entirely with Kotlin. Companies like Google, Netflix, Trello, and Airbnb have successfully adopted Kotlin for their Android apps. This widespread industry adoption demonstrates Kotlin's real-world viability and benefits. For new Android projects, Kotlin is frequently the default choice. Its seamless interoperability with Java ensures that existing Android APIs and libraries remain fully accessible. This has made the transition smooth and appealing for the vast Android developer community. Section 6. Getting hands-on simple Kotlin examples for Android. Let's look at a very basic Android task in Kotlin. Imagine you want to find A in your layout and set its text. In Java, this involves casting the result of. In Kotlin, with Android KTX extensions, this can be simpler. You might write, notice the direct property access for. Kotlin often allows for more direct and intuitive ways to interact with Android components. This reduction in boilerplate is a common theme. Even small improvements like this add up over the course of a project, making development faster. Now, let's consider handling a button click. In Java, you typically use an anonymous inner class for the. This can be quite verbose. Kotlin, with its support for lambdas, makes this much cleaner. You can set a click listener like this. The code within the curly braces is the lambda expression. This is significantly more concise than the Java equivalent. It clearly expresses the action to be performed when the button is clicked. Readability is greatly improved, making the code's intent immediately obvious to other developers. Here is a small exercise to try. Take the button click example from above. Modify the function or the lambda directly. Instead of just calling a function, try changing the text of another when the button is clicked. For instance, this simple exercise will help you practice using Kotlin syntax. It will also reinforce the concept of event handling in Android with Kotlin. Hands-on practice is the best way to solidify your understanding. Don't be afraid to experiment with small code changes. To continue your learning journey, there are many excellent resources available. The official Kotlin website, kotlinlang.org, offers comprehensive documentation and tutorials. The Android developer portal, developer.android.com, has extensive guides on using Kotlin for Android development. For interactive learning, try Kotlin koans. These are a series of exercises that teach you Kotlin syntax and features step by step. Many online platforms also offer courses on Kotlin and Android development with Kotlin. The active community ensures you can find help and examples for almost any problem you encounter. Section 7. Beyond mobile, Kotlin's expanding horizons. While Kotlin gained immense popularity through Android development, it is important to remember its versatility. Kotlin is a general-purpose programming language. Its design principles of pragmatism, conciseness, and safety are valuable across many domains. This means that learning Kotlin opens doors to various development opportunities, not just mobile apps. Developers skilled in Kotlin can apply their knowledge to server-side programming, web development, and even native applications. This adaptability makes Kotlin a very strategic language to learn for the future. It is not confined to a single platform or use case. Kotlin has made significant inroads into server-side development. It runs on the JVM, giving it access to the mature Java backend ecosystem. Popular frameworks like Spring Boot offer excellent first-class support for Kotlin. Developers can build robust and scalable web applications and microservices using Kotlin with Spring. Additionally, JetBrains developed Kotor, a lightweight framework built from the ground up in Kotlin. Kotor is designed for creating asynchronous servers and clients. Kotlin's features, such as coroutines for non-blocking I/O and concise syntax, make it an attractive choice for modern backend systems. Kotlin Multi-Platform Mobile, KMM, is an exciting development. It allows developers to share code between different platforms, particularly Android and iOS. With KMM, you can write common business logic, data handling, and connectivity layers in Kotlin. This shared module can then be used by native Android, Kotlin JVM, and iOS, Swift/Objective-C applications. This approach reduces development time and effort significantly. It also ensures consistency in the core logic across different platforms. While UI code remains platform-specific, sharing the underlying logic is a huge advantage for cross-platform projects. The reach of Kotlin extends even further. Kotlin.js enables developers to compile Kotlin code to JavaScript. This allows for writing client-side web applications using Kotlin's expressive syntax and strong typing. There is also Kotlin Native, which compiles Kotlin code directly to native binaries. These binaries can run without a virtual machine on various operating systems, including macOS, Linux, Windows, and even embedded systems. This broadens the scope of applications that can be built with Kotlin. The language's ecosystem is constantly evolving, opening up new and innovative use cases for developers to explore. Section 8. A thriving ecosystem, community, and resources for Kotlin. The Kotlin community has experienced remarkable growth since its inception. It is a vibrant, active, and enthusiastic group of developers worldwide. This strong community provides a supportive environment for both new and experienced programmers. If you encounter a problem or have a question, chances are someone has faced it before. Online forums, social media groups, and local meetups offer ample opportunities to connect with fellow Kotlin developers. This collective enthusiasm contributes significantly to the language's adoption and continued improvement. The sharing of knowledge and best practices is a key characteristic. Learning Kotlin is made easier by the abundance of high-quality resources. The official documentation provided by JetBrains on kotlinlang.org is comprehensive and well-maintained. It serves as an excellent starting point and reference. Numerous books have been written on Kotlin, catering to different skill levels and specializations. Online learning platforms offer a wide array of courses, from beginner tutorials to advanced topics. Kotlin koans, a set of interactive exercises, provide a fun and effective way to learn the language's syntax and core concepts. These resources make Kotlin accessible to anyone willing to learn. JetBrains, the creator of Kotlin, plays a crucial role in its ongoing development and success. They are deeply committed to the language and its ecosystem. JetBrains actively maintains and evolves Kotlin, releasing regular updates with new features and improvements. They actively listen to feedback from the developer community. This ensures that the language evolves in a practical and user-centric direction. The strong backing from a reputable company like JetBrains provides stability and confidence in Kotlin's long-term future. Their investment in tools and support is invaluable. The Kotlin ecosystem is rich with libraries, frameworks, and tools that enhance developer productivity. Many popular Java libraries work seamlessly with Kotlin. Additionally, a growing number of libraries are being developed as Kotlin First or Kotlin Native. IDE support for Kotlin is excellent, particularly in IntelliJ IDEA and Android Studio, both developed by JetBrains. These IDEs offer features like code completion, refactoring, and debugging specifically tailored for Kotlin. This robust ecosystem makes it easier to build complex applications efficiently. It provides developers with the tools they need to succeed. Section 9. Embracing Kotlin, your gateway to future-proof programming. In summary, Kotlin offers a compelling package of benefits for modern software development. Its core strengths are conciseness, safety, and seamless interoperability with Java. These features make the development process more enjoyable and efficient. They also contribute to building higher-quality software that is less prone to common errors. Kotlin allows developers to write cleaner, more expressive code. This is precisely what is needed in today's fast-paced technological landscape. The language is designed with the developer's productivity and happiness in mind, making it a joy to work with. Kotlin incorporates many modern language features thoughtfully. It learns from the successes and shortcomings of older languages. Features like null safety, data classes, extension functions, and coroutines are not just additions. They are well-integrated components that work together harmoniously. This thoughtful design helps developers write code that is both powerful and easy to understand. It encourages best practices such as immutability and structured concurrency. By adopting Kotlin, developers gain access to a toolset that is built for the challenges of contemporary software engineering. It is a language that feels fresh and relevant. The increasing adoption of Kotlin across the industry is a clear indicator of its value. More and more companies, from startups to large enterprises, are choosing Kotlin for their projects. This is true not only for Android development, but also for server-side applications and multi-platform projects. This growing demand translates into increased job opportunities for developers skilled in Kotlin. Learning Kotlin is therefore a smart career move. It aligns your skills with current industry trends and positions you for future growth. It demonstrates a commitment to using modern, effective tools. Learning Kotlin is a worthwhile investment for any programmer. It is relatively easy to pick up, especially for those already familiar with Java. The benefits in terms of productivity, code quality, and developer satisfaction are substantial. Kotlin is not just a fleeting trend, it is a language with a strong foundation and a bright future. By embracing Kotlin, you are equipping yourself with a powerful and versatile skill. It is a language designed for the future of programming, and that future is unfolding now. Take the step to explore Kotlin. You might find it to be your new favorite language.